We are starting a class this evening on R for beginners, mastering data science from your smartphone. That is using your smartphone to carry out data analysis using R. I want you to just bring out your phone as I'm already sharing my screen. Bring out your phone and set. I'm going to use R compiler. The application we are going to use for this training is R compiler. R compiler is an alternative to your RGUI or RStudio on laptop or computer generally. I hope you can see my screen. I'm using my phone now. What we need to do now, the first thing to do to use your smartphone to carry out analysis or do data science, just locate your Play Store on your smartphone. As I'm doing my own now, just go to Play Store. You can see me on my Play Store now. Look for it. Just go to search. Go to search. Just type is there. You are looking for R compiler. R compiler. Compiler. You can see R compiler. I want to show it to you. You can see this R programming compiler. You have installed. You can see installed on my own because it's already installed. So now just click. Your own will not reach install because you're just seeing it. You're just downloading it. So once you click on that, it will automatically download on your phone. Then you just click install. If you have installed it, you are going to see it coming up. It will be on your desktop, on your screen. So looking for the app, you can see it's here. It's already loaded here. So you just click on it. Locate it is here. You can see this R compiler you have downloaded. No, you may not have my own screen because you have different thing on your own screen, but just look for it. This R compiler here. Before I continue, I want to welcome people that are joining us. Okay. You can see 17 people watching. All right, no problem. Just follow me. Now we have a R compiler is here. When you click on it, just click on R compiler. I've already clicked on it. You are going to have this screen. You have a new screen. You can see this screen now. If you click on your own, it may not have this because I already worked on this before. You are going to have a new screen. This is a new screen. Now, before I type anything, I want to explain how it look like. You can see this is a blank screen. This is where you type your code, your command, all the function you want to use. You have them here. You can type them here. Please, let's just listen because I won't spend more time on this training. The essence of this training today is just to let you know that you can actually carry out many tasks on your phone without the laptop. Same thing goes with Python. I'm using R now. I've shown to you how to download it. You just go to your Play Store, look for R compiler, written together, no space. R compiler. Just go there. Uh, just to let people that are just joining us know what I'm talking about. This your Play Store. Look for your Play Store. Once you are there, you click on it. You can just search. Go to search. When you click on search, you have your search box. Type R compiler there. This is the color. You can see. So you may see another one, but this is what you are looking for. My own, you can see install there, meaning that I've already installed it. I don't need to reinstall. So for those that are doing it for the first time, you just click on install. It will download and install. Having done that, you click on open. So I can click on open here myself. You can see here. And if you don't want to use that, just go to your screen. See, you can delete all of this. You look for it here. You can see R compiler. It's already here on your phone. You just click on it. Once you click on it, you are going to, so it's going to load. You can see now. So this is the sample source. This is the default. It's going to give you this. Once you are done with the installation, you are going to have this default code. I hope you are doing it. If you are not doing it, you watch this over, and maybe after this training you can do it. You will see this the default code here. You see, print hello world. You see, simple pie chart. That simple pie chart, you have hash before it, and that is simple pie chart. When we use, I mentioned this last time, the first time we are meeting, that any statement you write after hash, we call it comment. And that hash signify, we call it hash comment. You want to make comments, so you are passing an instruction telling whoever is reading your code that this is what you are about to do. So you can see, you can see simple pie chart here after the hash. R will not execute any statement you write after the hash. You can see it. So slices C 10 12 4 16 8. What this one mean? You want to plot a pie chart here. You want to plot a pie chart. You know, those slices they are the sectors on your pie chart. So US is represented by 10, UK is represented by 12, Australia is represented by 4, Germany represented by 16, and the last country there is France, represented by 8. So you can see the function that plots pie chart is pi. You know, I told you last time we were meeting that to learn R is very easy. See, the function we use to plot is pi, and in English the name itself is pi. So you can see slices. We have already defined our slices here at the top. So the countries name, they are already there. So now you can see the LBLS there standing for the name of the, so they are the attributes name. They are the one that will be plotted with the values So if you plot this now, the name, if I just plot without using the name of the country, you won't know what those 12, 13, those 12, 4, 16, 8 stand for. So if I run this now, you will see the pie chart coming up. But let me tell you something before we continue. This version we are using is free version. And if you look at this the platform I'm using to type the code here, where you have sample source at the top, by the side of it at the top right corner, you see that green cursor there, that green arrow. That is what you are going to press, that will give you the execution. If I click on that, it's going to run this code. And to run this code, you will see it's running. But one thing I want to say here is that you may see advertisements. A lot of advertisements will come your way. You are going to be seeing them. You see them coming up. So if you see advertisements as you run this code, you have to just allow it to come because it's free. So it's a way of promoting their own work and to get their money. So just let it go. So when you are running it, you are going to see all of those, especially when you want to execute. Don't mind it. It's one of those things. Just bear with it. You are going to enjoy it. So this, if I want to run this now, I'm going to click this. Now before I move on, before I click run, I want to look at these 3 dots. The 3 dots has this menu: run selection, input, new, open, save as, clear. Each of these, it means whatever code you have typed here, you can save it on your phone. Don't forget, we are using her on our phone. This is not, I'm not using my laptop, I'm not using computer, I'm using my phone. You do with that, I just joined in. We started by going to Play Store. On Play Store, we search the app we are using. The name of the app we are using is R Compiler. Just look for it on the Play Store. So once you click on download, it's not heavy, and you're going to have it downloaded on your phone. Once you have it on your phone, then you will see how you can run the code. Now you have three dots by the side. When you click on these 3 dots, you have this menu. I'm trying to. So if you want to save, just click on save as, reference, all of those things. Then another thing I want to show you before I run this code. Down here, if you look at my screen, I believe you are seeing my screen. Let me move this away, move to this side. Now you can see this one. This is start, this is end, this is undo. You can see all this arrow. Everything you need on your normal laptop keyboard, they are here. All these sign, you can see we use all of this in R. This greater than, less than, this plus. You can see all this backslash, /, exclamation mark, at, hash. All of these things we normally use, they are here. You want to do regression, you want to do analysis of variance, you want to do summary statistics, they are here. So yes, so I can run this. If I want to run, I just click this. So when I click on this, you can see it's compiling. Hello world, it has printed it. Now hello world that you see the other time there, it has printed it here. And the pie chart, you see something green down there. When you look at your screen very well, something down there by the right hand side at the bottom part, you will see chart. Click on it. The pie chart is going to be loaded. It's going to come up as a file, rplot.pdf. It's going to come up as PDF. Click on it. Can you see? This is chart. Can see pie chart of countries. So this is the beauty of using your R on your phone. Now you can say we have UK, the US, France, Germany. These are the one called slices. They are the sectors. And if you want to convert to sectorial angles, You can do that. Okay. You can say Ademuluyi Bidemi. How are you? Victoria. Okay. Well, others that are joining us, we are not going to stay long on this training. So you can tell your friends to join. It's an opportunity for them to know that they can actually carry out analysis on their phone. Now let me go back and do some descriptive statistics. I want to do some descriptive statistics. I will clean this. You just clean. Now I want to do some descriptive statistics now on some generated data. For example, now assuming I want to have x and y. You are fond of using x and y in statistics, mathematics, no, x and y to just to represent data. So what do? You just come here. For those that are just joining, you don't forget to be where I am now. You just need to go to your Play Store on your smartphone. On your Play Store, just go to Play Store, look for R compiler. R compiler. Go and look for it. Search for R compiler. Once you spot it, download it and install it. So once you click on that, you are going to have this particular outlook. You are going to have this platform. This sample source will open to you. Then you can type your code. Now what do? Okay, those that are coming can say, all right, you are welcome. Taiwo Jegede Elizabeth and Scrunchies. Thank you. Others can join. Now I want to do something else, that is descriptive statistics. Descriptive statistics. I want to represent my data with this. I want to come up with a sample data. For example, 2, 4, just generating 1 will be here, put 6 here, 3 here. It's okay like this. Now I want my y to be, you can see where I'm picking all these tools. It's very easy to use, very easy to use. It all depends on your interest. So I want to make my y to be square of x. So just say x raised to power. How do we use raised to power here? We use caret. Here is caret. This is it. Raised to power 2. X raised to power 2. So you can see, once you do this, now okay, let's now say down here. Down here, I can now, okay, let me have a table first. Let me have a table. Say formulate a table. So how do you formulate a table here? The function we use to get a table on R is what we call data frame. So data frame, can see the option we call, that is one beautiful thing about it. It will give you, once you type the first 2 letters on R, either you are using RGUI or RStudio, or you are using it, you're using R compiler, the one I'm using for you now. Just type it, data frame. You are going to, the option will be given to you. Just so once you know it before, you just pick it. After this training, we will go and use live data. We use that of biochemistry. We use computer science. But today, I'm just trying to. Later, I'll tell you the reason why I'm using this kind of app, because this is R compiler on our smartphone. Now to convert this to a table to make it look better. So we have generated X, we also generated our Y. So I want it to look like a table. These are vectors. Now it's going to be X, comma, you can put a space, you may not put space, it's not compulsory you put a space. Then Y like this. Then you run this, it will give you can see, look at the table. When you look at the generated table here, this generated table is when you have your x is 2 4 1 6 3, because I've defined y to be square of x, so you are having y square of 2 is 4, square of 4 is 16, square of 1 is 1, square of 6 is 36, square of 3 is 9. That's generated it. Now you go back, compare your results. You can see, look at it. Even manually, if we change this now, if I change this one to something else, maybe I want it to be 5. Of course, you are going to get what's there. You are going to get 25. So run it. So we are having 2 4 6 5 6 3, and look at the corresponding value of your y. That is square of x. So you already have a table. So if it's a number of microorganisms you are counting from your microscope, maybe these are from different markets, you can actually have a table like this. But this is not just a example that what I'm giving you is not. I just frame this for you to understand. We can use live data from experiments. You see, from a laboratory, from field work, from survey. It's possible, quite possible. Now let's plot this. Let's plot it. You just say plot. You can see when you type PLO, you have not even finished typing. Already you have some word that be suggested for you. You just pick out of the suggestion. The first one is plot. The second plot you see here is plot.ts. Plot.ts has to do with time series data. There's going to be a training on Saturday. That's next tomorrow, 12 to 2. On NKTR user. It's on time series. Now, the TS in front of this plot is about time series. But I'm not going to use that. I want to use the first one. Now, plots, bracket open and close. So, you can see, I've told you that the first thing you see here, all these are tools you can use. Tab, and all these, you can pick what you need here. Now, plot, X. Now, the rule is, if you want to plot in R, your horizontal axis comes first. Your horizontal axis comes first. So you put your X, then you put comma. Then you can put your Y after the comma. Then you run. You can see when you run, you see something down here. When you click on it, it's already plotted. See, look at it. It has plotted it. Look at y-axis. You can see it contains the 5, 10, 15 up to 30. So that's how to do it. Then you can change the color. Can change the color. If you want to change the color, just come here, put a comma here. You say color is equal to Okay, look for equality sign. Well, we have over 600 colors in R, so I don't know, but since I don't know the position of each of them now, what I can do is to write the one I need in English. But if I want to use the number, if I want to use the number of the color, I can start from one. I will say the color, the corresponding color following the number. I will be given one now. Let me run it. One. So uh, sorry, I said is that one problem with this is that it will continue to give you advertisements. This one thing with it, you just have to allow it to come. So run this. We don't want to. So let me stop this. So they are already asking us to pay. So but if you want to do small one like just to get tables and run your analysis already like the one we did now, but the one that involve charts, the one that involve charts, we go pro version. But for us to do simple analysis like summary statistics, let me go back and do summary statistics, but the one that involves chart at times you have to go pro version. Now for example, now if I don't want to plot because plot is asking us to go pro version, so for example if I want to do summary statistics for this now, let me summarize. No, summary statistics has to, it's talking about descriptive statistics, the mean, the median, the passing, the minimum, the maximum. So I want to go summary statistics now. Let me delete this. Now summary, we call it summary. Open the bracket and close. You just say summary x y x y x. What you are going to use to put y here, then run. You can see minimum is 5, minimum is 2, first quarter is 3, median is 4, the mean is 4. You can see, and the third quarter is 5, and the maximum there is 6. You can see everything lining up for you. So you can see this result, just like as if you are doing it on your laptop. So the difference, no difference there. The only limitation you are having here is that there are some area where you are restricted, like the one that just came up now. You see, as you are working there, advertisement will come up, and some other time you want to do some complex analysis, or especially when it's going to involve charts, they may ask you to go pro. Apart from those limitations, R compiler can do. Now I want to move forward and do like t-test, but before that we show you some data that are built-in data sets. I will show them to you, then carry out some analysis on them. For example, let me leave these ones alone. Let me just delete all of this. I want to reveal some data just like the way I did the other time. Essence of today's training is to show you that you can actually carry out your analysis on your phone. Data set, or just data. Now this one will give you the data that are built in on her. So what I'm going to do here is just run. You can see data set in package data set. This is data set there's a particular package called datasets. So in datasets you have all this data. You can see all of this data. You can play around with this data. Therefore practice. You can see all of this data. There are many. I will show one. I will show some of us to us. You can see now. Okay, like air passenger, we have cheek weight. Let me pick cheek weight for those people that are in bio or microbiology. Or after that, I will show one to us again in another discipline. This is air passenger. If you can copy it, you can copy. But it's not. You just look at it very well. Air passenger. Look at the way it's written. You must write it the way it is written exactly. One is different, you are not going to get it loaded. So let's look at it. Air passenger. So just type air passenger. It's capital A R, then passenger, P A, passenger. I think it's passengers. Then you run. If it's not correct, it will not load it. Yes, it's correct. You can see air passenger. This is data on air passenger. Now if you want to pick another one, I think I saw cheek weight there the other time. Cheek weight. And I saw women also. Let me pick women. There's data called women. So this advertisement, that's one of the problem with it. Advertisement will always come, but you can just ignore. Okay, women, run. So when you run this, it will give you data on women. It's compiling women. That's why it's called R compiler. You will see now that data can be worked upon. One is done with the compilation. If it's something you can carry out chat on, is something you are going to deal with descriptive statistics. If it's going to be inferential statistics, you will see it, but it's still compiling it. This has to do with internet, but it's not going to consume much because the women itself, the data called women is not something so big. Okay, you can see we have height, you have weight. This is for women. We're talking about built-in data on her, just like your SPSS has built-in data which you can play around with, which you can work on, when you are testing, when you are practicing. Look at it. These are the height of 15 women with their weights. Can see now, just like the way I did the other time, you can plot height against weight and vice versa. So, and from this I want to carry out some just a simple summary on this. What I need to do, I will just say descriptive, summarize, that is summary. You just say okay, women, it will summarize those values there. You can see height as for height of women, the minimum height for the 15 women is 58. First quartile, that's the 25th percentile, 61.5. Median is 65, and so on like that. For their weight, you can see minimum is 115, maximum there is. So this is summary statistics, which we need for all our analysis. It's not just doing t-test and over all of them like that. We have some other things you can do, but this is just summary statistics I'm doing for you, which will give you overview of what you need. Now we can do analysis of variance, but before we can do analysis, what do we even use analysis of variance for? You must know all of these things. Subsequent training, I'm going to give you theory, some theories on how to know what analysis to carry out on a particular data. Let me look for one data like that. Data again. I will look for one data now. So okay, let's go for this biochemical oxygen demand, BOD. Let me look at what is here. BOD. I will just type BOD here, the data will come out for me. BOD, everything lowercase, uppercase. Run. So this is BOD, time and demand. This is time and demand. You can see the time and the demand for oxygen. So this is it. But I want to show one to us that has to do with that look experimental. You just to view the data again, you just type and put it there like that and load it. We want to have access to another data, so it will not be that I'm generating all of everything I need. You need to know how to access all this data and use them. Sorry, we have to do it with all this, otherwise they'll be disturbing us. Okay, we are using, let me use cheek weight. You can see the way it's written. Cheek weight. I want to use cheek weight now. Cheek weight. Cheek weight. I think the first one here is capital C, maybe capital W, capital C, capital W. So error. Let's put, I think it's a cheek weight. Yes, you can see cheek weight, you can see weight, time, cheek, diet. Now all of these are weight of chicken. How many of them? This one is a very, this is 578 chicken. This is a product of one experimental design. The time, the chick, the diet, kind of the type of chick and the diets given unto them. We have different kind of diet. One diet can come from one company, another one from another company. You want to test, you want to see which one is better in terms of their means. So we are going to do what we call comparison of means, and that's when we use analysis of variance. Now whether you are in statistics or not in statistics, every one of us will do statistics, we do comparison. That's why I'm bringing this example. Or later I will generate one for you to see, because if you are not in agric or you are not in biology, you might not know what we are talking about here. Now for this, what we normally do is to test. We want to carry out a test. That's ANOVA. We call it ANOVA, analysis of variance. We use ANOVA when you want to compare more than two groups. You want to compare the means of variables, more than two variables. You want to compare means of more than two variables, and we assume that the data itself, that's the response variable, is normally distributed. But that's an example I've shown to you. So what we use there is a analysis of variance. If it's just two groups, we use what we call t-test. So in this case, because we have many groups, so and that is what we are going to be using now for that. Now if it's when you have categorical data, like you are testing, you want to see the association between one group and the other group, like smoking against having cancer. It's expected that people that are smoking, that they will have cancer, either cancer of the lung or cancer of the heart or anything cancer. You know, people that are reading, students that read below 3 hours per day and grade in school, or pass or not passing, depend on number of hours you are spending in class. Or we can look at student welfare also. How many of them do their parents give them, maybe pocket money or not? Does it have any effect on their academic performance? So when we have data on that, we do what we call cross tabulation. And the tool to use in that case, at least for our own level, is what we call chi-square analysis. So you are going to do cross tabulation, but I will not go into all those ones today because of our time. Since I'm just introducing it to you, so please, I want to prepare against next class. Prepare your laptop, and I've always been telling students everywhere, learners, anything what do is working well. You can get laptop. You can borrow from your friend just for this course. Data science has come to stay. So the one I'm showing to you, you can see these disturbances, people, the advertisement here and there. This one is limited. There are some things you cannot do on your phone. But just to let you know that basic thing, you can actually carry them out on your phone. You can see me plotting and summarizing, and I will do one of them before I go again. That is regression. I will show it, but I will make sure I will not involve charts, so that they will not disturb me again. So after this, I'm going to let you go for today because it's just an introduction. But against next class, please make sure you have your laptop. You have your laptop. If I thought we are going to be using our compiler, it's going to be brief. So there are certain things you just have to prepare for. When we are talking about data analytics, you must know that you are going to describe your data. That's what I've just done, describing it using summary. What do? You just summarize, just type summary, and you put the name of the data inside. It will summarize to you, for you. Now another thing to test for relationship of data that are continuous in nature. You have to, you don't need to worry yourself with the code. With this data of era of AI can assist you in getting many of this code. You are not learning the way we learn it. So for example, let me generate another data for you to see what I'm talking about using regression. Now for example, if you have that of women is there for us. So the default or the code, the function we use for regression, let me put this there. Okay, regression analysis or simple regression analysis. It's simple because I'm going to use one variable. Simple regression analysis. Okay, I will just use something simple. Let me use something simple. Let's say sales. Okay, let me use hours. Hours of reading. Hours. When you are labeling like this, or you are assigning name to your variable, it should not have space. Hours reading. Reading. So can be okay. Hours you use for maybe just for 4 or 5 students. Hours of reading, somebody read for 3 hours, 5 hours, 2 hours, 6 hours per day, 9 hours per day. Let me make it 5 is enough because of time. Hours in reading. So let's look at scores of students. So this one will be okay, the scores of students now. Scores of students will be let's start from the first person that spent 3 hours in the class. Let it be 60 over 100 with 5 hours, and you can say 54. It doesn't matter at times. You may spend the whole hour in the class. You may not have better score. It depends on the rate of assimilation. So 67, the person with 2 hours, let me put 30 there, or 39. 6 hours, let this person go for 70. The last, make sure that the number of values you have, the items you have in one variable is equal to the number you have, because the second variable, that is your response, or the way you define it anyway, but they must align together, they must be the same. So 9 hours now can go for maybe 70 again. No, let it be 75. So you can see, like I said the other time, how will you change this one to a table that will make it look nicer? So it can be use data frame, or you just say table, or hour, or just say hour of reading, hour underscore reading. So you can just leave it like that. So you will say equals data frame, the function data frame, then you have this. You just write the one you want first. Hours. This one is too long. Let me change this one to small. Then this one, so I will not waste time. So this is hour underscore reading. That's reach. Comma. Put a comma there. Then we put the second one there, which is scores. Now you can see, no, we have assigned hour underscore reading to this. If I run this, it will not give me anything until I put the name of this table. The name of this table is hour underscore reading. So be very careful the way you type it. But I normally tell my students, make sure you copy and paste is better than just typing, so that you not make mistake of typing. When you run this one, you give us a table. There's something. Let's see. Reach, hour, reach, score. Something is wrong here. Let's run this first. Oh, so 1 2 3 4 5 1 2 3 4 5. So the hours of reading is different. We need to data. I cannot use the same thing I use for that data. So it was going to run this now to give us the table what we need. um, let's let's remove what we put here because it is saying that the same thing. Instead of that now, so this will give us the this hour of reading. This is cause let's see where the error is. The C here is gone. uh, so this is it. It has done it. You can see hour of reading. You can see scores. We have 3, 5, 2, 6, 9. We have 60, 54, 39, 70, 75. So you can see now it has given us, but we can, I want to actually give it a name. Let me give it a name. So let me give it reading data. Let me give it read data. Read data. Read data. Read data. So read data here is a is what we are going to use here. Run it and just say read underscore data. So it will give us, you can see now this hour of reading, this score. Now how do we now we want to carry out analysis, regression. We want to test the relationship between hour of reading and scores. We want to carry out analysis or reading. We want to regress scores on hour of reading. We want to carry out analysis on reading of scores. So what we are going to do is what we need to do now is to now carry out a regression. To carry out a regression. The regression I'm going to carry out here is to use, and the default, the code to carry out regression is LM. LM is linear model. It's linear model. So linear model. So you now say, okay, which one is the response variable here? The response variable here is score. You know that score depends on hour of reading. Don't make mistake of regressing hour of reading on scores. So if you do that, the idea that's you are already making mistake in designing your model. So you want to see the effect of hour of reading on score. So it's going to be scores, comma, hour of reading. Hour of reading is underscore read. So now when you run this, okay, this will not work. You have to use this sign of approximation. That's what we use to do regression. Yes, you can see this is located here on your laptop. This sign is located on the upper side of your keyboard, the left hand side. You see it. So you just that. So run it. Okay, before you run it, you can say read. Now to see the model here, because you have actually designed a model here, that is simple regression. You can add a summary, read data, read underscore data. So when you run this, we just have to bear with me, with all this coming up. So when you run this, you can see the results. So now, so this is the result. This is exactly what the result will be if you are doing it even on your laptop. Now look at it. The okay, if you let, you can You can turn it. You can turn uh, your phone. Uh, if you turn it other way around, it will show you how the results should look like. So you can see these are the residuals. These are the coefficients. This is intercept. If you want to write this equation now in regression, now look at this. You have estimates. These are the coefficients. If you want to write this one out, you know how to look like. So the response variable here is cost. You know the response variable here is cost. So the independent variable which is predictor is hour of rating. The intercept 37.43. This is the standard error. This is t value. This is probability value. And you can see a star in front of the intercept. That star signifies that shows something about p value. This is significant. We are not after the significance of the intercept anyway. We are looking at significance of the predictor, which is hour of reading. Now you can see a dot in front of it. That's one of the uniqueness of using R. Result, the p-value in R will tell you whether it's significant or not. If you have star, it shows that it's significant. If you have 2 star, it means it's highly significant. You know, the number of stars you have talk about how significant that result is or the predictor is to the model. So this 0.0629, you know, you say you reject your H naught, you reject your null hypothesis if your p-value is less than alpha or less or equal to alpha. Alpha here is 0.05. Now look at it. This one is 0.06. It's close to significant, but it's not significant. So that is it. You can actually write this one out. You can write it out. And you can see we have the R square here is 0.7359. That's see, you are saying that your model explains approximately 74% of the variation in the response variable. The variation in the response variable. So it's explained. So it means a good model. So this is above 60%. So shows that the model is okay. Now we can proceed from this place to to another thing. But this already, I promise that I'm not going to exceed 1 hour. This is already 1 hour here. So let me stop here. So you can drop your comments. But I think let me do a recap. Let me do a recap before I leave. For people that are just joining us or maybe wondering what are we doing? I'm just through with an example on regression. But how did we get to this point? This is doing data science on our smartphone. So we can actually carry out data analysis using our phone. As a data scientist or wherever you are coming from, you can carry out some analysis using your phone. SPS cannot be done here, but R is versatile and it's downloadable anyway. You can download it yourself and you can install it. All you need to do is just go to your Play Store. Just go to your Play Store. Get to your Play Store. Look for Play Store. Where is your Play Store? This is Play Store. This is your Play Store. Then go to search. Type R compiler there. R compiler. You can see this is how it look like. Can you see? See, anything outside this is not R compiler. This is R programming compiler. When you click on it, open. It takes you to this place. You can see. So this is how to run. You click this green arrow, it's going to run. Then anything you want to type here, you see all the keyboard coming up here. Everything you need, all the time we normally use, they are here. And I've used very many of them today. So please, this is the end of the training for today. I've seen us. Some of us were around, and those that are not around, ask them to go to the video and watch it, and you should go over and make their comments, whatever comment they have. And people that are watching us, I hope you have enjoyed it. So till next time, thanks and God bless. Bye. Can I see your comments? Yeah. Bye. Can I see your comments? Yeah.